Have you ever heard of the solar wind? This phenomenon plays a crucial role in influencing planets, including our own. Throughout this video, we will explore how the solar wind operates within our solar system and what effects it can have on life on Earth. Curious to learn more? Then don't miss a single second of this video. If you like what you see, don't forget to subscribe to our channel, like the video, and leave your comments. Enjoy watching. The solar wind is a stream of charged particles, mainly protons and electrons, that are expelled from the Sun's corona, its outer atmosphere, at incredibly high speeds, often exceeding 400 kilometers per second. This phenomenon is not random, it's the result of complex physical processes occurring within the Sun. Stars, like the Sun, are enormous spheres of hot gas that generate energy through nuclear fusion processes. During these processes, hydrogen nuclei combine to form helium, releasing vast amounts of energy. This energy manifests not only as visible light, it's accompanied by a continuous emission of radiation, which also includes electromagnetic radiation and subatomic particles. The particles that make up the solar wind accumulate in the Sun's corona and, due to the extremely high temperature, millions of degrees, gain the energy needed to escape the Sun's gravity. The solar wind isn't uniform, it varies depending on its origin and intensity. It can be categorized into fast solar wind. This stream of particles, which can travel at speeds exceeding 800 km per second, originates from active regions of the Sun, such as sunspots and solar flares. The fast solar wind is characterized by a lower particle density compared to the slow solar wind but has a much higher velocity. Slow solar wind. This particle stream is more constant and comes from the polar regions of the Sun. Although it travels at lower speeds, around 300,500 km per second, the slow solar wind is more persistently present in the solar system. As the solar wind travels through space, it can reach Earth in about 2-3 days, but its speed and intensity can vary. During solar storms, when the Sun emits a high number of charged particles, the solar wind can strike Earth with greater force, leading to phenomena like geomagnetic storms. The interaction between the solar wind and the planets is crucial for our understanding of the solar system. This interaction can significantly influence planetary atmospheres. For example, on Mars, the solar wind gradually eroded its atmosphere over billions of years, leaving the planet with a very thin and unprotected atmosphere. This process has contributed to making Mars an arid, inhospitable environment, lacking the atmospheric protection needed to support life as we know it on Earth. Additionally, the solar wind is closely linked to the phenomenon of polar auroras. When the charged particles from the solar wind interact with Earth's magnetic field, they can produce spectacular light displays in the polar regions, known as the Northern Lights, Aurora Borealis, and Southern Lights, Aurora Australis. These extraordinary light shows dance in the night sky, representing a clear sign of the interaction between the solar wind and our planet. Geomagnetic storms caused by the solar wind not only produce auroras but can also have harmful effects on modern technologies. They can cause communication disruptions. Geomagnetic storms can interfere with radio waves used for communications, causing temporary blackouts. Satellite damage. Charged particles can harm the electronic circuits of satellites, impairing their operation and increasing the risk of collisions. Power outages. During extreme events, like the famous Quebec blackout of 1989, geomagnetic storms can overload electrical grids, leading to large-scale power failures. But how does this interaction between the solar wind and planets occur? One key to understanding this phenomenon is the magnetic field of planets. Planets, including our own, have a magnetic field that surrounds them. This magnetic field acts as a protective shield, deflecting the charged particles of the solar wind. However, on certain occasions, the solar wind can overcome the defense of the magnetic field and penetrate the atmosphere of planets. This can happen, for example, during solar storms when the number of charged particles in the solar wind significantly increases. During these storms, the particles can interact with Earth's magnetic field and produce visible effects, like the aforementioned polar auroras, as well as invisible and potentially damaging effects on Earth's technology. Understanding the solar wind is essential for the future of space exploration. As scientists plan missions to other planets and celestial bodies, knowledge of solar wind dynamics becomes crucial to ensuring the safety of those missions. For example, future colonies on Mars will need to contend with atmospheric erosion caused by the solar wind and may require innovative solutions to protect habitats and equipment. Furthermore, continuous observation of the solar wind via space probes, such as the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe, provides valuable data for predicting solar storms and mitigating their effects on Earth. The solar wind is a vital phenomenon in interplanetary space. The charged particles expelled by stars interact with the planets in the solar system, affecting their atmospheres, magnetic fields, and environmental conditions. Understanding this interaction is fundamental to our comprehension of the solar system and its effects on Earth. Ongoing research continues to reveal new aspects of this phenomenon, and our ability to monitor the solar wind and its interactions is constantly improving thanks to technological advances. Thank you for watching and stay tuned as our journey through the vast universe continues.